for this to be seen. But this object has higher internal energy. Explain, or maybe 3 marks, 4 marks, they ask you to explain. Okay, what I?
Larger intermolecular forces of attraction. So,
You haven't hit the right answer. Say.
molecules are closer together.
Yes, that is the answer. Why? Why larger mass means you have high internal energies? Can you explain? Larger mass means larger what? Means larger total PE and total KE. The word is total. Okay. Imagine 10 people and 10 billion people. Who has more KE? Obviously, more people, more molecules, more KE, right? Total KE. Tell me, 10 people more PE or 10 billion people more PE? Obviously 10 billion people because more intermolecular forces of attraction, right? Correct or not? So mass is a very important factor in determining the internal energy of a system. You understand? The more the number of molecules, the more the total KE and total PE. Okay? So in our mind, a lot of students they thought that wow, high temperature must be very high internal energy. But not always like that. You must care about the number of molecules. Okay? And higher total KE and total PE. Okay. So this part is like that, internal energy. Next, we move on to talk about the thing that you always don't care, which is this one. Let's say water. Okay. Now, this is the full formula for the energy supply.
No, I did not feel
Okay. Now, see, so they give you testimony. She got 100 marks for 2 consecutive tests for maths. Give you testimony. Okay, see, now, this one, this one is always, we learned already in Sec 4, right? However, now I show you what is real A level. This one is, I never go through this because Sec 4 you already learned already, MC, theta, ML. This is the entire possible list of questions. Why like that? Because when we heat up something, the thing may increase temperature, may change state, right? Why I write container? Because you heat up something, you may heat up the container as well, right? So a lot of students, they only thought that when you heat up something, you only heat up the water. In actual fact, not necessary. You can heat up the container. And some more got heat loss. Okay? Now, we see an A-level question on this.
This C square is inside or outside? The square is inside or It's the right. This square thing is inside or outside?
The root mean square speed, then you square that. Oh, some still don't understand root mean square speed. Okay. Root mean square speed now. You have one molecule here, move 2 meters per second. Another molecule here, 3 meters per second. Another molecule here, 4 meters per second. Okay, tell me, how to find the root mean square speed? Okay, you know root mean square speed. First, you will square it, then mean it, then root it. How to square it? Square it first, don't care, square it. Then, mean it. That means what? That means 2 square plus 3 square plus 4 square divided by 3. This is what? This is what? This is C square, you know. This is called what? This is mean square speed. You must know the name of exam for test one. This is called mean square speed. You want to find C? Is what? root everything, right? I bring here, root everything. This is called root mean square speed. Don't mix up. Okay? Now, we have one very good question for A level from RJC. Wait, let me see the. No. RJ no good. This one. Got it. RJ. Now, number 5. Everybody, based on what I taught you, try number 5. This is A level question. I'm not asking you O level stuff. No other formula, only this formula. Have you seen this kind before? Maybe.
Okay, one check two for breakfast.
I only get one check. Everything is done right now. Yeah, you want
And you have 1 minute, 3 minutes. Because MCQ is 1.5 minutes.
Fusion material.
C. Is that? Is it C? I don't know why. I see what you say here. I don't know what count. Is it like here?
A.
Here's it. Okay. Okay. See, the rule is very simple. Now, this is only one of the questions. Sometimes they give you MC theta. Okay. Now, the main concept for this question is you must understand that the power, the rate of heat loss is the same for all the cases, regardless of what power you use. However, heat loss increases when we use increasing power. You understand what I mean? I say again, if you use higher power, means you will have higher heat loss. Okay? Common sense, right? You use something very, very powerful to heat something. Wow, the thing must lose a lot of energy, right? Must be fast, must be more is lost. However, the rate of heat loss is the same. Rate means how fast it lost to the surrounding is the same. Now that's why we can just eliminate the term by this. See, a lot of students when you do in the exam, they will totally forget about heat loss, you know, right? They only remember MC and ML, they forget about heat loss. In A level, this is crucial. Okay, you must remember this as one of the criteria. The rest are just MC and ML. If you think you need required additional practices, let me know. I'll pin for you and you can do that, or you can bring them and do it.
Wait, Mr. Lai, so if you say higher power, higher heat loss, then how do we minus? So usually they will ask in the form of
Higher power means higher heat loss. But you see, I convert to rate of heat loss.
So the question is
Usually like that.
Like that, right?
Yeah, usually like that. But unfortunately, last year the A level skill A planning question, last 2 years, I don't remember which year, they got asked about this stuff. They got asked about using heating effect to heat up something to determine the efficiency of a solar panel. So I think everybody cannot do that. Many students cannot do it, including the top 5 students. But doesn't matter. That's why I say you don't worry too much about the planning and data analysis. Okay. The main thing is, I mean, if you are in the verge, not in the A region, now you still just pass or whatever, you don't care those things first. You care the main core first of the topics. But if you're already in the A or B region, then you do more the data analysis or the planning. Because that one is unpredictable. You cannot predict one. That one is very high advanced level of thinking. Impossible to tell you in one lesson how to do all the planning question, very hard. You must be good in those topics first. Then you have experience. Then only you can do your planning well. And planning also require, how to say, on the spot reaction. Think on the spot. Very, very hard to teach. This one, you must be good in your topical first, okay? Now this one is done. Now, the second thing is okay. Tell me, what is this thing? What is this thing? This is called the
Thermodynamics.
first law of thermodynamics. What is the definition of first law of thermodynamics?
Increase in U, increase in internal energy, the sound of the heat supply to the system and go down.
Yes. Just recite I'm going to recite everything. Every recite, see the like mantra like that. You know. I recite mantra. Okay. This one, increase of internal energy is the heat supply to the system and work done on the system, right? Now, what is this formula? Okay. This one is only true for monoatomic gas. Okay, I said before, right? What is the meaning of monoatomic gas? 3/2 nRT U is only true for mono. Is it like the mono? Monoatomic, right? Monoatomic gas. This one, 5/2 nRT is for diatomic gas. 7/2 nRT. Later you know lah. This is triatomic. Okay, what does this mean? Remember, they don't need to know so many detail where all this comes from. Just remember. In exam, it's very clear. They'll tell you this is a monoatomic like the question later. Monoatomic gas use this. Diatomic like hydrogen gas, H2. Ozone layer, O3. Okay? Then you use this thing. 99% come out this one. Okay? So this is additional info for you in case they go crazy. They go and ask this kind of thing. Then you also know, right? Okay. Next. After, what is the significance of knowing all these things? We need to use this knowledge to explain the PV graphs. Okay? This process 1, process 2, process 3, process 4. Okay? Now listen carefully. Now I want to revive your memory. I do not know, some don't know. But don't worry, after this you will know. If you don't know, ask me again. Okay? Now, PV graph is the main thing we need to understand for this last part of thermal physics. If the people really will ask, because in the past I thought that 07, 08, 09, 10 never asked. Suddenly they come out again in 11 and 12. So I guess they'll come out again. Okay, so you please must know this very, very well. Now, you need to, from all these processes, you need to know the 6 changes of the variables. Delta U, Q, W, P, V, T. And the process 1, process 2, process 3,
Is process 4 curve
and
or
process
straight?
4.
Is process 4 curve or straight?
A straight line. Now, delta U, Q, and W, put plus, minus, or 0. This one put increase, decrease, or constant. Okay, before that, let me teach you how to do the first part, the rest you do yourself, okay? Now, we need to understand there are a few kind of processes here. One is called the isothermal process. What is the meaning of isothermal? Temperature is constant, means delta T is 0, means delta U is 0. Because delta T, temperature constant means delta T 0, right? Delta T 0 means delta U is 0. Okay. Second is adiabatic. Hey, how to prove? How to prove? Can you tell me? How to prove is isothermal process?
Temperature never changes. PV equal to NRT. PV over NR is constant. PV over NR is constant. T1 we got oh yeah.
This one only. This one only. Remember, okay? What is adiabatic?
Q equal to 0.
Yes, good. By now, being over idea, brain over must know many things, huh? Okay. Q equal to 0. What about isovolumetric?
Delta V is
It's also called isochoric.
W0.
V0. Sorry, delta V0.
W0.
So W is P delta V also 0. Okay, that means no change of volume. Alright? Can, huh? This thing, I do not know whether you learned before or not, but you don't care, you learn now, okay? Remember all these things. Now, next, we need to learn how all these processes affects 6 variables. If you can see how the 6 variable changes during each processes, you are successful already in this section. Okay, very easy. First of all, how do we analyze first process? I do first for you, 2, 3, 4, you do yourself, okay? Now, very, very simple. First is, you use this formula. Look here, look here. This is 1. Another is this one. Only 2 formula you need to look at. Hey, you don't copy first, you copy later. Listen. Very important. Now, see how I approach the question. First thing is, you have a PV graph. You just need to get the information from the PV graph. Very simple. See how the P and V change, right? No. So see the first process. What about P? P is increasing, right? What about V? Constant, right? Yeah. So you know the P and V already. Hey, do you know that from here PV is proportional to T? Right? So PV you know. P times V is dropping, right? So temperature also dropping, right? And when the temperature is dropping, that means the delta T is negative, right?
Yeah.
The negative delta T, so directly you can see delta U, right? If from here you have shoom, come to here. Then from here, shoom, come to here. So this must be negative, right? Understand? Alright. Now, do you know that from the graph directly, we can see W directly?
Yes.
How to see?
Oh, whether
Whether it's compression or expansion. W is positive when compression. Remember, you see, how to see compression? Volume drops, right? You see, this one volume per drop.
yeah.
No, volume change same, volume don't change, right? So volume, no change. So W is 0. Correct?
Sorry.
I say again, W can see instantly on positive or negative. Compression means positive. Expansion means negative. As simple as that. Okay? Now, hey, you know delta U already. You know W already. Can you find Q?
Yeah.
Obviously, right? So this must be. Can you fill up the rest? Oh, by the way, this process 3, I would like this to be adiabatic. I don't like isotope. I like it. Isotope, I tell you already, how to put P1, P2, P2. If you can answer all this correctly, you know, that means you understood already how to see the 6 variables.
The special effect in your here.
Pressure.
Yeah.
No direct effect.
Not very good. It temperature cannot change. Elevator temperature can change.
Adiabatic has nothing to do with temperature.
So it's independent.
Adiabatic has something to do with Q only. Any indirect change, I don't know. It's a direct effect. Don't think that adiabatic means no change of temperature. It's wrong. No input or output of heat only. Q is 0. Q is heat supply and heat loss, not temperature. Don't mix up. Q.
Very interesting.
Adiabatic only means Q is 0. Nothing to do with temperature directly.
I see.